Hi, Accelerated. Today we are working on linear equations. We're going to see three separate ways to write the same type of equation. So as you guys probably know / remember, linear equations are straight lines, right? So not a parabola or a cubic function or anything, but a straight line. And they often look like this. And there are sort of three things that we think about with linear equations. So the first one is the slope, and the slope is the rise over the run. It's how the graph is moving. Is it moving up? Is it moving down? So for the slope for this one, I just go ahead and find a point that's at a lattice line where those grid lines are coming together. And then I'm going to go ahead and find another one. So that's not a very easy point. This is not a very easy point, but this is a pretty solid point. So I'm going to use those two big points, and I'm going to say, okay, how much did it rise and how much did it run? We always run to the right. So we have 1, 2, it went up, and run 1, 2, 3, it went to the right. So our slope in this case would be the rise over run, or 2 over 3. When we're thinking about the y-intercept, we're thinking about where it touches the y-axis. Right, so here's the line here. Where does it cross the y-axis? Well, crosses right here at -2. So we'd say the y-intercept is -2. And then the 0 point, also known as a solution, is where it crosses the x-axis. It's the x-intercept. So we have our line here. We have the x-axis here. So 0 would be at this point here, which is at 3. So our 0 would be 3. So that's just some key vocab that you might need: slope, y-intercept, and 0. We have three separate formats that our equations might come in. We have standard form here, slope-intercept form. That's probably the most common one that you've seen, y equals mx plus b. And then point slope form, which is this version here. That's probably the least familiar version you have. So we'll start with standard form here. And standard form has a number in front of x, and then either an addition or subtraction sign, and then a number in front of y, and then an equal sign, and then it equals a number. All right, so that's how you'll know that it's in standard form, ax plus by equals c. And one way that you probably have done this before is like you've just solved it for y. You've just gotten y by itself, so like move the 2x over and then divided by -3. That is totally fine. If you want to do it that way, you can. There is another way to do it, which is to find the x-intercept and the y-intercept. So if you're looking at this graph and you know that you want to find the x-intercept, that's where y equals 0. So what we want to do is we want to set y equal to 0. So I'd say 2x minus 3 times 0 equals 12. So let me go ahead and move this down here. We're going to set y equal to 0 to find the x-intercept. So that's basically going to make this 0. So 2x equals 12. So x is equal to 6. So when y equals 0, x equals 6. So I could write the coordinate point 6, 0, like that. If I want to find the y-intercept, I could do the exact same thing, but when it crosses the y-axis is at x equals 0. So in this case, we're going to set x equal to 0. So we'd have 2 times 0 minus 3y equals 12. 2 times 0 is just 0. So I have -3y equals 12. I'm going to divide by -3. I have y equals -4. So when x is equal to 0, right, because that's what we made our x equal to, then y is equal to -4. So now we have 2 points, super easy to graph. So I'm going to go ahead and graph 6, 0 over here, and 0, -4 right here. And that allows me to draw a straight line right through them, just like that. I want to make sure that I'm also going through this way. I'm going to go ahead and draw this line super straight. Use technology to make mine super straight. And that's how we can graph it. So standard form is very simple to graph this way because it makes, you're either like crossing out the x or you're crossing out the y. It makes it very simple to find the intercepts. So that is standard form. The next form that we're going to think about is probably the one we're most comfortable with, slope-intercept form. So slope-intercept form is y equals mx plus b. Remember that m stands for slope and b stands for your y-intercept. So that's why it's called slope-intercept form. So this here, whatever number is in front of x is your slope. Whatever number is after x is your y-intercept. So the easiest way to graph is to find the y-intercept, which is -4, and then use the slope, which is up 2 over 3. Remember, that's our rise over run. So on my graph, I'm going to go ahead and go to -4 on my graph, right? That's my y-intercept, so where it crosses the y-axis. And then the slope is +2, run of 3. So I'm going to go ahead and go up 2 and over 3, put a point, up 2 over 3, put a point, up 2 over 3, put a point. So I have that point there. And then once I have those points, I can go ahead and draw my line straight through them, all the way to the edge, put an arrow. I can also work backwards, down 3 backwards, or down 2 backwards 3, like so. Go ahead and continue that line straight through here, arrow on the end. I want to clean it up by just erasing those extra dots. Any extra dots, I want to clean those up. And that is how I can draw this line, just like this. So that is slope-intercept form. And then finally, we're going to deal with point-slope form. So point-slope form is written with one point, and the slope. So we can still see the slope right here with the m value. So we know this slope is going to be 2/3. And then the point that they're giving us is x1, y1. And notice that in the equation, there are minus signs here, right? There are minus signs there. That means that the minus sign is a part of the equation. So for example, if I was looking for what x1 is, the minus is coming along with it. So x in this case is just 3, +3 in this case, because the minus is already a part of the formula. In this case here, I see that the minus has turned into a plus. So this is like minus -2, kind of like that. Y minus minus. Remember, because the negative and a negative make a positive. So if the minus from the original formula is here, then the y1 is -2. So the point is -2, like that. So the point that we're going to start at, rather than the y-intercept, the point where we're going to start is 3, -2. And the slope that we're going to use is still 2/3. If that feels complicated, like the negative thing, something that you might just like pretty easily remember is that it's the point is the opposite of what you see. So if you see that the x is -3, you would switch that to be +3. And if you see y +2, you would switch that to be -2. So you can see that's the same as this positive-negative version. That's just the reason why. The formula comes with a negative, and so we want to use the opposite of it. So what we do is we go to this critical point, which is 3, -2. 1, 2, 3, -2, right here. And then we use the same slope, or we use the slope from the formula, which is it's located in the same location, right here, 2/3. So I'm going to go up 2, up 1, 2, over 3, 1, 2, 3. Same backwards as well. And then go ahead and draw a line through it, like so. I'm going to put an arrow. You might notice we graphed the same line 3 times. It was the exact same line, which means that these equations, go ahead and clean this up here a little bit. These equations, this equation, and this equation, all describe the exact same line. They describe this line here, right? What that means is that, I mean, you can start to see some of the numbers, right? So if we were to take that, what I was talking about, and like move the 2x over here and then divide by -3, right? You could see this would be just y, this would end up being -4. There's that -4. And this would be positive 2/3 x, positive 2/3 x. So we can see that those are related to each other, right? This one's a little bit more complicated, but we could do the exact same thing. We could distribute this in here like this. We get 2/3 x, and then 2/3 times -3 is -2. We have y plus 2, so I'd subtract 2 on this side, and I would get y equals 2/3 x minus 4, which is exactly the same as this. Math magic! So excited. Very cool. We have 3 different versions: standard form, slope intercept, and point slope form. You're going to graph each of them using IXL, and then you'll take your check. So that is it. Let me know if you have any questions. Thanks, guys.